The pattern you see on the screen is a common point of confusion among beginner programmers. It seems counterintuitive as most of us grow up counting things the regular way, starting from 1. Despite this, most programming languages still use zero based indexing, and while some well known exceptions do exist, indexing arrays from 0 remains the de facto standard to this day. As an inexperienced programmer, it's easy to think that this is somehow related to the fact that computers operate based on the ones and zeros, or perhaps because counting starts from 0 in binary numbers. As you get more experienced at working with zero indexed arrays, you might start noticing that this approach also comes with some convenience factors. For example, trying to represent a multi-dimensional structure in memory, such as a game board, using a single array, works out much cleaner when working with zero-based indexing. However, the real reason is actually in how arrays are stored in memory, and how this memory is addressed by your computer. The array data structure is defined as a fixed-sized collection of elements which are stored in a single continuous block of memory. This is different from other, more complex data structures such as a linked list, where individual elements are stored in completely separate places in memory. For example, an array of 8 elements, each 4 bytes in size, would be stored as a single 32-byte long block of memory. A common mental model to make zero-based indexing more intuitive is to think of the index as an offset from the beginning of the array. That is, how many steps away from the beginning is the element located. This way, the first element of the array is actually 0 steps away from the beginning. While this may appear as a simple mental trick, this model is actually the real reason why we use zero-based indexing. In a programming language like C, a reference to an array is actually just a pointer to the beginning of the array. So when we access the nth element, we're actually accessing the memory address n steps away from the beginning. At compile time, the array index is converted into basic pointer arithmetic, adding n multiplied by the size of the element type to the array reference. In C, the all familiar square bracket notation is actually just syntactic sugar. It's simply a more convenient and less error-prone way of accessing an element at a known memory offset. It's worth noting that, in modern languages, the implementation of basic built-in list-like data structures is often more complicated under the hood, and array indices in this case aren't necessarily equivalent to offsets in memory the same way that they are in C. Nevertheless, this little design choice from over 50 years ago has permanently solidified itself in the world of programming, and will most likely be a source of confusion for new programmers in many years to come. Hope you enjoyed this video. Next time you work with arrays, remember that zero-based indexing isn't magic. It's a design choice that lines up with how memory addressing works at a hardware level. See you in the next one.